Okay, so this is where we got to in our notes, factoring trinomials. And what we need to do before we talk about how to factor a trinomial is kind of think about what happens when we multiply two binomials. So remember, in this lesson so far, we've talked about factoring polynomials that have a common factor. You factor out the common factor, and then we talked about factoring a difference of squares, a plus b and a minus b. So now we're going to talk about factoring trinomials, and trinomials are just a polynomial that has three terms, and they won't have a common factor, but they can still be factored. And so first of all, before we try to do that, let's look at what happens when you multiply two binomials. So if I multiply x plus 3 times x plus 8, I'm going to FOIL it like this. I'm going to do the distributive property and figure all that out. So x times x is x squared, and then x times 8, that's plus 8x, and then 3 times x, so that's plus 3x, and then 3 times 8 makes plus 24. So if you add the like terms here, you get x squared plus 11x plus 24. Now, when we're factoring, we're going to be starting with this, something like this, and we're going to want to get it back to factored like this into two binomials. So we have to look at this and see what the relationship is between what we started with and what we ended up with. And if you look at it, you've got your 3 and your 8 here, and you've got this final term, the constant, which is the product of these two numbers. And then you've got the middle term, the x term, which is the sum of these two numbers. And that's how it's always going to work out. So if I had a problem like this, where I want to factor x squared plus 11x plus 24, I would start out with two sets of parentheses, and I would think about, okay, where am I going to get x squared from? Well, that would be the first thing I would do, would be to multiply x times x is x squared. So my first two letters, just like up here, are an x and an x to get x squared. And then I would look at the final term, which is 24, and I would think about, well, these two numbers here are going to be factors of 24, because the last thing I do is multiply this times this, and that's where this number comes from. So these two numbers have to multiply together to be 24, so it could be 1 and 24, it could be 2 and 12, it could be 3 and 8, it could be 4 and 6. So any of those are possibilities, but the other limitation is that the two numbers have to add up to 11, and the only two that are going to work here would be the 3 and the 8. So I'd have a 3 here and an 8 here, and that would be the factorization of this trinomial, x plus 3 times x plus 8, and if you multiply it out, just like we did here, it's the same exact thing, you get this. So we're unfoiling trinomials. We're trying to break a trinomial up into two binomials. So let's look at some more examples. Alright, so we have this problem right here. We want to factor x squared plus 2x minus 35x. So we're going to make two sets of parentheses, and we're going to put an x here and an x here to get x squared, our first term. And then we know that these two numbers that we're going to put here have to multiply together to give us 35. Alright, well, actually negative 35, because we've got a negative sign here. So one of these numbers is going to have to be positive and one's going to have to be negative in order for us to get negative 35, because a negative times a positive is a negative. So let's look at the multiples of 35. There's 1 and 35. That multiplies together to give you 35. 2 doesn't go into 35. 3 doesn't. 4 doesn't. 5 goes into 35 7 times, and really those are all the multiples you have for 35. You can either do 1 and 35 or 5 and 7. So I'm pretty sure we're going to need to use 5 and 7 because we want to get a 2 here in this middle term. So is there any way that you can combine 5 and 7 to get positive 2? This is a positive 2. So you can if you make the 7 positive and the 5 negative. So negative 5x plus positive 7x is going to give us positive 2x. And that way this will work out, because if I multiply it out, x times x is x squared, x times 7 is plus 7x, negative 5 times x is negative 5x, and negative 5 times positive 7 is negative 35. So if I add the like terms here, that's x squared, plus 2x minus 35, which is what we wanted. Okay, so we need to make sure, once we factor it out, we need to make sure that it really is the correct factorization. But this would be the answer. This would be the factorization of this trinomial. We broke it up into two binomials. So let's look at some more examples. For that. Alright, so we've got 2x squared plus 11x plus 9. We want to factor this. Alright, well, in this case, now we've got a 2x squared, so that's a little bit different from what we've had before. Instead of putting an x and an x, we're going to have to put a 2x and an x, because that will multiply together to give us 2x squared. So our first term has to be 2x squared now. Alright, so now we're going to have to deal with that too, because it's going to affect other things. But we still know that the two numbers we're looking for have to multiply together to give us 9, because this constant term, the last term of the trinomial, comes from multiplying these two numbers. So it's either got to be 9 and 1 or 3 and 3. Those are the only multiples of 9. Alright, so we need them to, let's try 3 and 3, because it's more likely going to be 3 and 3. So let's just look at where this 11x is supposed to come from. Alright, it comes from when we multiply this times this and this times this. So 2x times 3 is 6x, and then another 3x. Does that give us 11? Can you get 6 and 3 to make 11? No, you can't. So 3 and 3 is not going to work. So the only other choice is 9 and 1. So we could put a 9 here and a 1 here. Well, let's see what we get. We get 2x here from that multiplication and 9x from that multiplication. 9x and 2x does equal 11x. So we can put a plus sign here and a plus sign here, and we're done. Because if we multiply this out, we're going to get 2x squared plus 2x plus 9x plus 9. And that is 2x squared plus 11x plus 9, which is what we started with. So this is the correct factorization. Alright, so this involves trial and error. When you do these problems, you don't just automatically know what the answer is going to be. You have to do trial and error. And try a couple of things sometimes to get the correct thing. Alright, now always remember that when you are going to factor something, the first thing you should look for is a common factor. So in this problem here, this looks a lot more complicated, but if we notice that there is a common factor of 4 in all three of these things, then we can go ahead and factor out the 4 before we even try to factor the trinomial. So if we factor out the 4, we're left with x squared for our first term. We're left with negative 7x for the second term. And we're left with 30 for the third term. So this makes things a little more simple now. The 4 just sits here out in front, but now we're going to factor what's left into two binomials. So we've got the x squared at the beginning, so we can just put x and x. And then we've got a 30 here. We want to get 30 when we multiply these last two numbers, and that means we need multiples of 30. So those are 1 and 30, 2 and 15, 3 and 10, 4 doesn't go into 30, 5 and 6, and that's it. Alright, so we've got to figure out which two of those are going to give us, we need it to be a negative 30, so one of them is going to have to be negative and one's going to have to be positive, because the only way you can get a negative when you multiply is to multiply positive times negative. Alright, so we need it to be a negative 7. So which of these numbers could we combine in any way to get negative 7? And that's going to be 3 and 10. If we make the 10 negative and the 3 positive, we'll have minus 10x plus 3x, which will give us a negative 7x. So this would be the final factorization for that trinomial. Alright, let's try a couple. Well, we'll just end here and I'll do some more examples on another video.